Hello everyone, welcome to 2019 Midas webinar for modeling analysis design for telecommunication and transmission tower today. My name is Kim Tae-guk from Midas IT technical team and I'll be the presenter for today's webinar. If you have any questions during the session, you can send your question message through GoToWebinar application. I will start with a brief company introduction of Midas IT from now. Midas IT is an engineering software development and distribution company established from South Korea. And now we have several global branch offices and plenty of professionals and users in the world. More than 30,000 of users are using Midas software in over 120 countries, and we are eager to support our valuable users in many countries. Midas has a worldwide network, and there are 7 official branch offices in USA, UK, Russia, India, China, Japan, and Philippines. Besides, there are also a lot of partners in other countries to support our software to the engineers. Already, many of global level of companies are using Midas software in their projects in many of places, which means the software is already verified in the practical project fields in the world. There are main 4 categories of software lineup in Midas: building, bridge, geotechnical, and mechanical engineering fields. Today we will be focusing on Midas Gen software for building and infrastructure engineering. Those who are interested in our other part of software, please contact us for more detailed information. Using Midas Gen, we can handle various types of structure for building and general types as well. Burj Khalifa is the one of tallest building in the world from Dubai in UAE. Midas Gen has been used as one of design tools for this project. Midas Gen is also widely used for the steel structure such as plant engineering, stadium, airport, and so on. Back to the main topic, we are going to discuss about modeling analysis and design for steel tower as per American code today. And the last of the session, I'm going to introduce very useful software, Midas Design Plus, which is a unit member design tool. So that would be the today's session. For the steel tower, 3 types of steel tower are commonly used in practical: self-supporting tower, guide tower, and monopole. The towers that are supported on ground or on buildings are called as self-supporting towers. Uh, though the weight of these towers is more, it requires less space area and suitable in many situations. Most of televisions, power transmission, floodlight towers, telecommunication towers are this type. Guide towers are normally guide in 3 directions. This tower is much lighter than self-supporting tower type, but requires a large free space to anchor guide wires. There are other restrictions to mount dish antenna on these towers and require large anchor blocks to hold the ropes. Monopole is a single self-supporting pole, and this is generally placed over roof of high-rise buildings. when number of antenna required is less or height of tower required is less than 9 meter. We are going to deal with a self-supporting type tower today, and this is a design overview. For the load combination, condition, we will apply dead load without appurtenance, and wind load as per TIA ASCE code. We will not consider the earthquake load for this example. Also, we will check the model analysis result as well as steel member design as per AISC code. So the model is quite simple. We will now look at the software Midas. So this is Midas software. So Midas software, as I said, this software we can handle building as well as the infrastructure and many different type of the general structure. So the as you see here, the interface, we have the menu system here. So the menu system is ribbon menu style, and then the menu are in order of our working process. So starting from view, so you can actually follow your working process, structure and node element. We can do the model and properties, boundary and loadings and analysis results, and you can do the design. So the menu, all the menus you can find here in the ribbon menu. And we also have small icon menus. These icon menus you can use in the modeling or other steps very quickly. And we have tree menu system. So tree menu is you can find 5 different tabs. So menus and tables. So here you can find any types of tables, geometry tables or property tables, loading tables, any kinds of tables you can find here in the tables tree menu. And works trees is something you can do like a model information. So whichever the function you use, it will directly show here in the works tree. So now we will start from the modeling of the steel tower. So here in Midas, there are several ways you can start for the modeling. So first you can go to menu, file menu, and there is import system here in Midas. So here you can see we can import AutoCAD DXF file, or if you want, you can also import other software model file such as SEP 2000 or StatPro model file directly into Midas. So these model files is not importing only for model geometry, but also you can import boundary or loading condition together with the model file. So this is the first way you can start for the modeling. And the other steps, you can go to structure, and there is a grid system. So here you can use define point grid or line grid for your modeling. So using the grid system is second way to start the modeling. And also the next is you can directly starting the modeling from the scratch. So if you have some frame model, you can directly go to node element, and there is a create nodes, the node modeling or element modeling. You can find various type of the modeling functions here in the node element. And also there's other way you can start. So if you go to structures, so here in the structure we have a wizard system. So using the wizard you can model typical type of structure very quickly. So in Midas we have this tower wizard. So tower wizard we have tower leg, body and arm. So today we will going to use these tower leg and body functions to model our transmission tower. So I will start with the tower leg first. So when you open tower leg, you can see this kind of dialog box. So here in the tower leg, we have now 4 different tower leg here. So you can change your length of your width, and then you can also change your number of panels, and here you can also change your select type, front and then plane. So I will use the same. I will use the default select type for the front and plane. So when you change your dimension, and then you can click modify, then you can change your size of the first leg. So other leg I will also change same. I will also apply the same input data for the other leg. So using these 4 different dimensions, you can modify your tower leg size by yourself. So as you see here in the figures, it will directly affect it when you modify your dimension. So after you finish, you input the size here or the select type and other options. So you can click apply to import your tower leg wizard into your model. So as you see here, our tower leg has been imported in our model view. So after you check our tower leg is successfully imported in the model view, you can now close your dialog. And now we will going to generate our tower body. So tower body, you can also modify your size. So in tower body, so tower body we have W1 and W2. So I will input 8 meter and then 3 meter. So here you can add the components here for tower body, the type horizontal and then vertical. So vertical you can change row of redundant. So I will input 2 row of redundant, and then I will change the type with this type. So you can use different type of redundant. And then the first height I will input 5 meter. So when I click add, you can now see the first now you can see the first body here. And now you can sorry, I will change the size here first. And now I will add different shapes here, and then click on add again. So adding these different type of bodies, the program will interpolate this linear size of the W1 and W2. So the W1 will be 8 meter and then W2 will be 3 meter. So we can add different body modules here in the tower body. So this will be the second shapes. And then third shapes I will change also to this type. And then the height I will change 4 meter. And then click on add. And now we will also use the same shapes of this one, and then 4 meter, same thing, and I will click on add. And the next one I will also use the same one, and then the height I will change to 3 meter, and then you can click on add. So if you want to use the horizontal part, you can also change the horizontal, and then you can add the intermediate this horizontal body. I will change the redundant number, row of redundant to 1. So next I will change also the size, height, 1.5 meter, and then the shapes using this one, and click on add. So as you see here, we have this type now, and then on the top of this body I will use the horizontal type. And then horizontal, you can use different shapes, different type of your horizontal. I will use the default one. So you can add to insert your horizontal type of body. So now you can insert this body into your model. So if you see here the origin point, now you can see the origin point. So you can you can actually detect your insert point when you click your mouse button. So now it will detect -4, -4, 0. So now you can click on apply. So you can check your model, your tower body has been successfully inserted in your model. And now we can close. So as you see here, you can see we first generated our first leg, and then we added this tower body. And next one, we will add another body type. So you can go to tower and then tower body again. So we will again add the another tower body. So now we will add W1 as 3 meter, W2 as 1.5 meter. So using this tower body or tower leg wizard, you can quickly just add your modules, and then you can generate this tower modeling very quickly using the wizard option. So we will use the same shapes type of the second body. So this one I will use the height as 2 meter. Click on add, and then another shapes, the same one, and then the height 2 meter. Click on add, and then also the different type, these shapes 2 meter. Click on add. And I will also change the shapes 2 meter again. Click on add, and also one more. I will click on add. So if you change your height, it will add more modules in the height, but the bottom width W1 and then top width W2 will be fixed as you insert here, and then program will linearly interpolate the size of your body modules. And then finally, in the top position, we will also use the horizontal type here, and then click on add. So now we have this 16 meter level of the second body. So this one you can also here in the model, you can click insert point, and then you can detect the point here, and then you can click apply button. Then now you can check your tower model body has been successfully inserted. So after you finish your after you check if your model is okay, we can close the wizard. Now we have this type of telecommunication tower, steel tower. So here in the Midas, third module is tower arm. So tower arm is used for mainly for transmission tower. So you can use your arm body and then left arm or right arm. So you can change your number of panels, or you can change the front type direction and diagonal directions. So you can change your types. So the plan type, you can also change this type. So using tower arm, we can also easily model this kind of tower arm for the transmission tower. So for our example, we will not use this tower arm wizard. We will just use the leg and then body options. So after we finish our modeling, now we will apply the properties and then the loadings, and then we will see the analysis and then design result of this steel tower. So in Midas, we have several section data in our library. So using different countries' database of the steel sections, you can also use the American standard for the steel data. So as you see here, typical shapes of this section, we already have the library for different countries. And also, if you have this irregular shape of your sections, which we don't have in the library, then you can use the AutoCAD section data of your sections, and then you can import those section in CAD format, and then you can automatically calculate your section property by the software automatically. And then this section data you can actually import into the model view. So in the software Midas, you can you can see the actual section shapes in the model view, and then you can check the orientation of this member as well as, and then you can see the sections in the structure itself. So let's apply the material and section data. So go back to the model. So here in the properties, before we will insert property. So actually in this model we actually used these wizard options, but if you want to add the other member in this model, you can just use this create element button, and then here you can just click 2 point to generate other member type. So not only using the wizard, you can also modify very easily using other create elements or translate, extrude, other element generation options. So go back to the property. So we will add material property first. So in the works tree, as you see here, the steel material has been already defined by the software. Since we has used our tower wizard, program applied the default material and then section data in our library. So you can go to this property here in the works tree, and then we will change into American Standard A36 material, and then when you select the database here in the material, then program will show you the steel material data in this dialog. So modulus of elasticity or Poisson's ratio, and then other material properties you can see here. So we will use American Standard. And then also the section properties. So as you can see, so this program already used the default one. So these code settings, you can also change your preference code settings for the material or section data. Now we will change the section data to American Standard. So we will use the first section for this one. So we can use these sections. So now I want to change other sections. So as you see here, the main post or redundant, and then bracings, those elements already defined as the default sections. So now I want to change with the same section property with this one. Then how we can modify quickly? So we can also change similarly using drag and drop. So I can double click this, and then you can drag and then drop to your model, then it will change the same section data. But now I want to change all these different sections. So how we can change? You can go to these sections. You can mouse right button click, and then you can go to tables. So here you can see the section data of your model. So this section is database and user section, so we can change to the second tab. And this is the our table of the sections. So you can directly change here in the tables, but we will use the Excel format import. So here is the Excel. So you can copy Control C from our software data, Control C, and then you can go to Excel and you can actually paste your data. So here I want to use the all same sections. Go down, and then we can select the all same these tables, and then Control D. We can actually use. I will change all these same sections, and now I can just select all my data, and then Control C, and you can here Control V. So you don't need to modify one by one by clicking. If you can use the Excel, then we can just directly copy the data from the software, and then you can modify in the Excel, and then you can just paste to your model. So the software is compatible with Excel data. You can directly change all the information using the Excel format. So now we change the section data, and then if you want to change your sections by different groups, so if you go to group here, since we has used the tower wizard, program already make the group for different part, so redundant, and then main post, and then main bracing. So using this grouping option, you can directly change the section shapes with different type of your members. It has already defined the 3 different groups. I will use the wireframe mode to see more clear view for the model. So after that, we will use the boundary support. So boundary condition, you can select here in the boundary. So here, as you see, we already defined the boundary since we has used the wizard. So in the tower wizard, there is the boundary condition control. So you can actually choose pin over none. So default option is pin. So program already defined the boundary condition. So if you want to manually define your boundary condition, you can go to boundary, and then here in the define supports. So we can apply the support, the fixed condition, pin condition using these options. So after properties and then boundaries, now we will apply the loadings. So I will go back to the presentation. So this webinar, we will more focus on the American code for the steel tower design. So as you know already, in the American standard, we can use ASCE code for the steel design. But here in the for the steel tower, most of the engineers are using TIA standard, TR standard for the steel tower. So most of my contents today is following the TIA standard, and also AISC and ASCE standard. So in the load combination written in the TIA, so symbols of notations, in the steel tower, we can consider the dead load, and then dead load of the structure and appurtenances, excluding guy assemblies, and then dead load of guy assemblies, and then earthquake load, and then temperature loading, and then wind load. So today we will not consider the earthquake for the steel tower. So we will use for the dead load and the wind load. So here, if you see, we can also see the load combinations for these strength limit state load combinations. So in the software, I will first add the load cases for our model. So first is dead load. So I will insert as DL name, and then you can select the type dead load. Click on add, and then wind load. I will apply for X and Y direction separately. So wind load on structures, and then wind load for Y directions, structures. We can click close, and then the load combination function is under result tab in the load combination. So here in the steel design second tab, you can actually auto generate your load combination as per AISC code. So now we don't have any load case loading for dead load and the wind load. So if you use auto generate, program generate the load combination as per AISC code. But also you can directly generate your load case using this spreadsheet form. So you can change the name or active and then type, and also dead load. If we see the code, so we can use the 1.2 dead load, and then 1.6 wind load, and then 0.9 1.6. So you can actually directly change here in the table format 1.2 and 1.6. And similarly, using your tables, so for example, if you have the Excel data for existing load combination data in your computer, then you can directly copy your Excel into this spreadsheet form in load combination. That's also available in the software. So now we will apply the self-weight of dead load. So here in the load tab, we already defined the load cases. So now we can go to self-weight and then choose dead load group, load case, and then you can insert -1 in the Z direction, which means it's the vertical, negative vertical direction to the ground direction. And then you can click on add. So in this way, you can apply the self-weight into your model. And next is wind load. So here in Midas, we have auto generation functions for wind load. So first we will apply the story data for this structure. So go to control data and then story. So here you can use auto generate story data. So program will detect the jet level for the node position. You can click on OK. then we can go to load tab and then wind load. So these wind loads is the automatic generation functions for wind load as per the code. So we can click on add, and here you can select the code. So we can use the ASCE7 10 or 5 and then 98, and also other countries code. So this one we will use the ASCE705. This is the similar code for the TIA standard. I will save this model. So we will go back to the presentation. So for the wind load, design wind force on structure, if you see in the standard. So for the FST, so you can see the QZ and GH and EPAS. So here in the code, the QZ is the velocity pressures, and it expressed here using the KZ and KZT and KD, and also large V and then I. So I just include the images, the standard here with these factors. So velocity pressure coefficient is KZ. So KZ, if you see here, there is a factor Z and then ZG. And ZG are tabulated in the table 2-4. In the 2-4 table, we actually should select the exposure category B, C, and D. Exposure category B, C, and D. So based on these exposure categories, Z or alpha and then K factor is varied. So in the software here, using this code base, we can use the wind load parameters as exposure category. So exposure category, you can select this exposure category B, C, or D. We will apply the wind load later after I explain this. So in the wind load, in the next for the velocity pressure factor is KZT. This is the topography factor. So for the escarpment or ridge or axisymmetry hills, so considering these topography factors, actually we can apply the KZT factors. And based on the tables here in the hill shapes, two-dimensional ridges or escarpment hill, so we can apply different factor for the this KZT formula. So in the software, if you go to this topography effects in the this small option button, then you can see the topography effects hill shapes for the X and Y direction. So using only the basic factor here, like hill height H and then hill length L, you can just insert these factors and then program will calculate for these topography effects. This example will not use this effect. We will just use as the default one. And the next factor is KD. This one is wind direction property factor. So this directional factor, as you see here in the option box, already program select point A5. So if you want to change, you can change your own values. So lattice structure with triangular square is using this point A5, so we will use the same thing. And then importance factors. So based on structure class 1, 2, and 3, based on this structure class, so wind load will be changed for this without ice factor will be changed. So importance factor is this I factor. And then basic wind speed large B is based on your region. So now this webinar is not only for only one specific region, but as you see here in the TIA standard or other standard, it will generally provide you the wind speed, basic wind speed based on specific region. So there are a lot of the different basic wind speed. We will use the default 85 mile per hour. We will use the default one. So referring your region, the code, you can directly change this speed, wind speed. So using this option box, you can define your KZ, KZT, and then KD, and basic wind speed V, and then importance factor I. So based on these all factors, program will calculate the velocity pressure QZ. And gust effect factor. So program use this default one, 0.851. But if you want to consider this gust effect as well, then you can go to this option box, and then program also show you the gust effect factor for rigid structure. So this one you can also choose the exposure category, and then based on your structure height and then breadth, program can calculate automatically for the gust effect factor. So based on your structural height, gust effect factor is between 0.85 to 1. So you can just click calculate to use gust effect factor. And then design wind force on structure. So based on your effective projected area of lattice structures. So this one is expressed EPA. So this one we can use the load evaluation using force coefficient. So this one we will use the 3.4 factors based on CF. So we can now apply the wind load here. So we can use the analytical procedure, and then base wind speed using the same thing. We will use the exposure category as D, and then importance factor we can use 1. And then direction factor, topography effects, we will not use direction factor, we will use the default one. And then gust effect factor, we will use the program calculated one. So the mean roof height already program knows that is 47.5 meter. And then we can click on calculate, and then gust effect factor, we can click on OK to insert. And load evaluation, we will use the 3.4. And then direction, since we will use the direction for X and Y direction, we will use this one as 0. So if as per the code, we can also apply the 45-degree direction for the wind load. So that we will not consider that one for today's example. So here we can click on apply, and the X direction wind load has been applied, and then we can change to the Y, and the direction we can change 0, and then Y is 1. Click on apply. So here in the wind load profile button, so you can check in the software story force, story shear, and overturning moment. And then using make wind load calculation sheet, so you can also check your calculation process of this wind load. So now we applied wind load for X and Y direction. And now we will go to analysis. Since we want to consider the mode shapes, I will use 20 different mode shapes for the structures. So here in the analysis, and then eigenvalue analysis data, so you can apply your mode shape analysis, modal analysis. So here in the worktree, you can check the analysis control eigenvalue has been applied, and then story, and then nodes, and then element, and properties. So you can check your model information here. So now we will click on analysis button. So go to structure type. We will consider the self-weight into mass data for the eigenvalue analysis. So now we finish the analysis here. So if you go to message window, you can check your Midas job is successfully completed. So after you finish your analysis, you can go to analysis results, and here you can go to load combination, and load combination, as I said, now you can generate your load combination as per the code. So here you can see your load combination will be generated by this standard. So here in the result tab, you can check reactions or deformation, and then force, stresses, and then other diagrams. So we will check on reaction forces first. So you can select the load cases or load combinations. So I want to see the dead load reaction forces first. Vertical direction Fz, and then values together, and then legend together. You can select the items you want to see and click on apply buttons. So you can check your reaction forces on your structure, and then it will express red color as the maximum reaction forces. And for the wind load, you can also select the wind load for X and Y direction, and then you can check the reaction forces for the lateral direction. And for the displacement contour or deformed shapes, you can also check your deformation, displacement based on load combinations. And then you can check your displacement here in the legend. If you want to see the different unit system, you can also change the units here. And then the forces of your members. So you can also check your force for your members. And also for the mode shapes, you can go to modal shape here, and then vibration mode shapes. So you can actually check the tables data in this small option button or in the result table, and you can go to vibration mode shapes. So in the tables, as you can see here, the modal shapes. So this x direction is governed participation in the first mode and then third mode and sixth mode, and y direction second, fourth, and then seventh, and z is 8. So here in the modal shapes, you can see in the first mode, and then contour type, legend, click apply, you can check your modal shapes. And for the y direction was second mode is governed, so you can click apply. Or if you want to see the multimodal shapes, you can go to multi-mode, and then you can select the components which you want to see and click OK. Then program will generate the several different modal shapes in your software. So you can check on the different modal shapes. So this is how we can check the reactions or displacement and forces, and also the modal shapes of our structure. And now we will move on design part. So in the design part, you can also change your general design parameter. So program, we have the function auto calculate effective length factor. And if you want to insert your own effective length factor, you can also go to here in the general design parameter effective length factor k, and then also you can insert your own values, or you can select the typical k factor. And in the steel design, you can also choose the code, AISC code. We will use this code for today. And after that, you can also change the strength reduction factors or modify steel material serviceability parameter. You can change these design options. After that, we can go to steel code check. So when you do the steel code check, program will show you the code checking data. So since we use the standard, and then here you can see in the table format the small type and then the expanded type. So you can check the member number, combined ratio, or section number, and then the section sizes, and then the yield strengths, load combinations, and so on. You can check all this information here in the tables. And when you want to see the graphic format of this report, you can go to graphic here, and then you can see the summary types of report here. And also, if you want to see the detailed calculation process, you can go to this detail. And program can generate the detailed calculation process text format. So you can check all the step-by-step calculation as per the code. So using this detailed report, you can easily find the differences between your hand calculation with the software. So whenever you find the error or the different result, you can directly go to this detail report. And also you can now, if you want to see these change options, in the change options, you can click search satisfied section button between the limit combined ratio from 0.8 to 1, which means program will show you the expected section size based on your structure. Using the search satisfied section, program will find the suitable section size between the combined ratio of 0.8 to 1. You can also change this combined ratio from other scope. So program will show you the available sections here. So you can select, and then you can also change this member to analyze again. And then and here in the so here in the steel cold form design, in the result tab, so you can actually see in the graphical format of your member design result. So it shows with the values together, or you can also see in the legend which part my member is failed or passed. So this is how we can do the steel tower design using Midas. Starting from the modeling, and also we apply the loading for self-weight and then wind load, and then we can see the design result as per the American standard for the steel members. So now I will show you the Design Plus program briefly, and then we will have the question sessions, Q&A session. Okay, so the Design Plus you can actually find in the tools in the Design Plus here. So in order to show you the other part, I will use different model file. So Design Plus is under here in the Tools tab. So in the Tools tab, you can open Design Plus here. So in the Design Plus, this is the not the 3D model analysis software. This is 2D software based on the this code based as per the code. So here in the RC steel or SRC, we have several design modules for slab, beam, column, or shear wall footings, iso footing, combined footing, or basement wall, cantilever retaining wall, and buttress stair, and then steel beam plus column or base plate, and then bolt connection for shear and then moment connection, and then crane girder design or purlin girth design, web opening or steel stair design. And then composite SRC composite, we have composite beam design and composite column design. So this is not the 3D software. For example, if I show you slab module, so as you see here, this is slab module for the design. You can insert your material data, concrete or steel, rebar, and then design node, you can increase your design node, and then the dimension, you can also change your dimension, and then span and thickness, and then cover, and slab type, one-way slab or two-way slab, and then you can also change support condition. So basically the input options, you can change the parameters in one pages for all these design for slab. So type or rebar size, and then after that you can click on design or check options. Then program will design or checking for your input data here. So in the table format, you can check the design result if it's okay or not. And then here in the report, so you can see in the summary type report, and then detail type report. So summary type is showing only the design result, and then detail type program will show you the step-by-step calculation process together. And this report format you can save as image file or PDF file, and even Microsoft Word format file. So you can generate the Word format file here. And also this one, you can use different modules here as well. For example, for the footings. So for footing design, you can choose similarly concrete material and then rebar material, and then loading, serviceability loading or factored loading. And also you can choose the surcharge load, and then you can change your type footing, footing type, mat footing, pile cap footing, and also you can change the eccentricity of your columns, and then you can change number of piles, and the rebar size, spacing, and also you can do the checking. So it's very quick software. So there's no you don't need any learning material or learning curve for this software use. Since once you use this software, you already know what is the concept of this software and then how to use it. And here, as you see, you can see the summary type report or detail report. So in the detail report, you can see the step-by-step calculation, moment capacity or shear, and then two-way shear, punching shear check. So you can see all the calculation process. And also in this, using this software is very we have very good feature, which is Midas link option. So this Midas Gen software, in the structural part, we have for example, we have building model, and this one we can actually link Midas link Gen program together, connect. And now if I go to Gen software, and you can select this node of the footing positions, and then go back to Design Plus, it will show here as the node positions, and then you can change the option to import your node positions. Then when you import your nodal position of your 3D structure, it will directly insert here in the different 6 node. So as you see here, the load has been imported together, and then column size has been imported together. So you can check load combinations, or you can check this node size, loading sizes, loading values, and then you can design for these members. So since we have different 6 nodes, we also provide the Excel format. So using this Excel format, you can also directly change your input data in the table format. You can directly change your data in the table format. And also, if I move to drawings, then you can select just RC footing and then click create button. And then you can generate your drawings. So this drawing already in DWG file format. So DWG DXF file format, you can just save as AutoCAD format. So we have various different type of the modules. So retaining wall. So also you can change the factors, parameters for retaining wall, and then you can do the design for your retaining wall. Or in the steel part, we have base plate or connections, moment connections, and or crane girder and so on. So for the base plate, you can also increase the force, the biaxial moment, or you can also change the shapes, H section or box pipe angle channel sections. or you can also use the stiffener for wing plate or rib plate, and then you can do the design for base plate. And also for the drawings, you can just select steel base plate and then create button. You can generate your drawings as per AutoCAD format. And those who are using the composite beam design, we can also use the composite beam design as per American code. So you can select the materials and then slab thickness, or you can use deck plate sections, or deck plate directions, and then the loading, live load and then finish load, and then you can increase the loading, and then you can design for composite beam. And also for the quantity takeoff, you can just use RC, for example, footings, create button. Then you can see the design by the case by case, the quantity takeoff in this table format. So this is all about today's webinar sessions. So if you have any questions, you can ask the question from now.